Hello guys, welcome to Maths and Science Aid. In this video, we'll be doing question 2 from November 2019 DBE exam. And this question is usually on sequences and series. Before we proceed with the video, I would recommend that you pause it and attempt the questions. For the first part of the question, we are given a quadratic sequence 321, 290, 261, 234. And the first question is write down the values of the next two terms of the sequence. And to do this, we can take down the terms of the quadratic sequence as they have given us. And then this is a quadratic sequence, so we are expecting to have a constant second difference because that is a characteristic of quadratic sequences. So we can start by finding the difference between the consecutive terms in the original sequence. And so remember that, for example, for the first two terms, in order for us to find that difference, we subtract the first term 321 from the second term 290. So we say 290 minus 321. And using our calculator, we can find that this is equal to, so 290 minus 321 is equal to negative 31. So this is negative 31. And likewise, for the next two consecutive terms, which is 261 and 290, we can find the difference by subtracting 290 from 261. And this will give us the difference, and so 261 minus 290 is equal to negative 29. So we get negative 29. So it is important to note that whenever you are calculating the difference, if you have a term Tn, you subtract the previous term Tn minus 1 in order for you to find the difference. And so even for the last two terms in our sequence, so we will have 234 minus 261, and that gives us negative 27. Okay, and so now we can also find the second difference now from the first difference, right? And it's the same thing even here. So for the first two consecutive terms, we will have a difference. So we say negative 29 minus negative 31. I hope you can note how I have added brackets there. That is very important. And if we do that, we'll get an answer which is equal to 2. And even for the next two consecutive terms, we can do the same thing. So we will have minus 27, and from that we subtract minus 29. And we're expecting to get 2 because this is a second difference of a quadratic sequence, and we expect it to be constant. And so basically, the first difference from a quadratic sequence is actually an arithmetic sequence, which is why when you are finding the difference from that first difference, you get a constant difference. Okay? And now, in order for us to answer the question, okay, we can work backwards. The difference that is going to be between the next term in the second difference and this negative 27 term must be equal to 2. Since we do not know what that term is, we can call it x. And so we know that x minus negative 27 must be equal to 2. And so we can work out the value of x here. And to do that, we know that a negative multiplied by a negative is a positive. So we will have positive 27. We still have 2 there, which means that x is going to be equal to 2 minus 27, which is going to be equal to negative 25. So the x value there, which is the next term in the first difference, must be equal to negative 25, right? And likewise, we know that this negative 25 is going to be the difference between 234 and the next term in our sequence. So we do not know it at the moment, we can call it y. And then we know that y minus the 234 must equal to negative 25. Okay, and so we can solve for our y value there, and it is going to be equal to negative 25 plus 234. And if we use our calculator, we can see that negative 25 plus 234 is equal to 209. So the y value there must be 209. 209 is the next term in our sequence. So we can apply now the exact same thing in order for us to find the second next term of our sequence. And so we know that in order for us to get this term, we simply need to add 2 to negative 25. That's what we have proven through algebra. So it means that the next term here is going to be negative 23. And then we can also find now our final term there. Using the same procedure, we simply need to add this negative 23 to 209, or we need to add 209 to negative 23. So minus 23 plus 209 will give us the next term, which is going to be equal to 186. So these are the next two terms of our sequence. And the question was only asking us to write down the values of these next two terms, which basically means that you are not required to show all of this working. All that they are expecting you to do is to give the next two terms, and then you get your 2 marks. 2.1.2 says determine the general term of the sequence in the form Tn is equal to an squared plus bn plus c, and that is for 4 marks. So to do this one, we can use our working from the previous question. And now for a quadratic sequence, we know that the constant difference is always equal to 2a, and the first term in the second difference here is always given by 3a plus b. And we also know that the first term here in the sequence is equal to a plus b plus c. And therefore, using these equations, we can be able to solve for a, b, and c, and thus determine the general term of the quadratic sequence. And so we can start by finding the a value from the equation 2a is equal to 2. We can obviously divide by 2 on both sides of the equation here, and we will find that a is equal to 1. Thereafter, we can take this a value and substitute it in to the equation 3a plus b is equal to negative 31. So we sub in 1 there, which we have found from the previous step. And thereafter, 3 multiplied by 1 is obviously just 3, which means that b is going to be equal to negative 31 minus 3, right? Which means that b will be given by negative 34. And now, lastly, we can work out c from the equation a plus b plus c is equal to 321, right? Because we know that the value for a is 1. We have also shown that the value for b is negative 34. So plus negative 34, and c is our only unknown. So that is equal to 321. Obviously, a positive multiplied by a negative is a negative. So we have negative 34 plus c equals to 321. And thereafter, we can combine 1 minus 34 and we will get minus 33. We can then add 33 on both sides of the equation, so that we'll be left with c on this side, and then we'll have 321 plus 33. Therefore, c is going to be equal to 354. And now that we have got all these values, we can just simply substitute them in to our general term. And so we'll find that Tn is equal to, in place of a, we write 1, so we are going to have n squared, and b is negative 34, so we have negative 34n, and then plus c, which is equal to 354. And so this is our general term for our quadratic sequence. And we can verify it, whether or not it is correct, by finding any of the terms that make our sequence. And so, for example, if we want to find the second term here, we can substitute 2 in place of n. So we would have 2 squared minus 34 multiplied by 2 plus 354. And this is equal to 290, which is exactly our second term. We can even test one of the terms that we had found in the previous question. And so this was term number, so 1, 2, 3, 4, 5. So it was term number 5. So in place of n, we substitute in 5. So we have 5 squared minus 34 multiplied by 5 plus 354, and it's equal to 209. And so this confirms that our general term is correct. The next question is, which term or which terms of the sequence will have a value of 74? And so to answer this question, we can make use of the general term or general formula that we found in the previous question. And as shown there, our general formula is Tn is equal to n squared minus 34n plus 354. And so in order for us to answer this question, we can just substitute in 74 in place of Tn, because Tn here in the general formula is the value for any nth term in the sequence. So in our case, the nth term that we are looking for has a value of 74, and we want to know which term is that going to be. In other words, we want to solve for n. Okay, and so this is how our equation is going to look like. And now the next thing is we want to take 74 to the right hand side of the equation. So we'll be left with 0 on the left hand side. And then on the right hand side we have n squared minus 34n plus 354 minus 74. Okay, and so this will be equal to n squared minus 34n, and then we need to work out 354 minus 74, and that is equal to 280. So our C value or our constant term is now going to be 280. And from here, I would propose that we use the quadratic formula for us to find the n values for which this equation is valid. And we know that the quadratic formula is going to tell us that n is equal to negative b plus or minus square root of b squared minus 4ac. All of this divided by 2a. And so n is going to be equal to negative b is equal to negative 34. We have plus or minus square root of negative 34 squared minus 4a, which is 1, multiplied by c, which is 280. Okay, and then we divide all of that by 2a. So we divide it by 2 multiplied by 1, because a is equal to 1. And now all that we need to do is to find our two n values. And obviously, the first n value here, we can say it will be when we are taking the positive here. And so we can use our calculator and work it out. So we have negative multiplied by negative 34 plus square root of negative 34 squared minus 4ac, which is 280. And then we divide by 2a, or 2 multiplied by 1. And so we see that we get n equals to 20. And so Let's see the second n value, whereby we take the negative there. And so that n value, so we write a negative there, and we see that we get n is equal to 14. Okay, so for our sequence, we are going to have two terms that will have a value of 74, and it is going to be term number 20 and term number 14. Now, the next question is, which term in the sequence has the least value? Okay, and so to answer this question, you need to remember that a graph of a quadratic sequence would be parabola. So it would look somehow like this, right? And so for a parabola like this, you would have a certain point along the x-axis whereby your graph changes direction. And this point here is a minimum. And so it would be the smallest value along your parabola. If we were to represent our sequence graphically, and I want you to recall that for our particular sequence here, we had found that the general term or the general formula is given by this equation. Okay, and now if we translate this into a graph, it would be a parabola that is a smile, like this one that I have drawn, since our a value is positive. And now, in addition, along the y-axis, it means that we would get the values of our nth terms. And then along the x-axis, we would have n, right? And so now, in the previous question, we shown that when the value of Tn is equal to 74, we are going to have n equals to 20 and n is equal to 14. Or in other words, we are going to have two terms, which are term 20 and term 14, that are going to have that value. So for example, if we were to say that 74 is about there, it means that we have got two terms, right? We have term that has an n value of 14 and a term that has an nth value of 20. And both of these are going to have a value of 74, right? And now we want a term that is going to have the least value. And it's clear if we're looking on our graph here that it would be a term that is going to be along this point here, which forms a turning point, because that point there would have the least value on our graph. And so this is simply a turning point of the parabola here. And from functions, we know that we can find the turning point of a parabola using this formula. So since we have n along the x-axis, we are going to say n is equal to negative b divided by 2a. And this is the formula that you can use to find a turning point. And from the general term of our sequence, we see that b is equal to negative 34. And so we divide that by 2 multiplied by a. And so using our calculator, we will see that n is going to be equal to, so negative multiplied by negative 34 divided by 2 multiplied by 1, which is obviously just the same as 2. So that is equal to 17. All right, so it means that the term in the sequence that will have the least value, it will be term number 17. But of course, this is not the only way on which you can solve this problem or on which you can find that turning point. An alternative way that you can follow, and depending on whether you have already learned that, which will depend on the time on which you are watching this video. So the alternative thing that you could do is you can apply calculus. Okay, using calculus, we can find the turning point here of our parabola by finding the first derivative of our function. So our general term here is the representation of our function. So if we let our general term here to be a function, so we let Tn be our function f of n, since n is our variable there. So we can find the first derivative of our function f of n, which is going to be equal to 2n minus 34. Okay, so we know that at the turning point of our parabola, f prime of n, which is the first derivative, is going to be equal to 0, because the first derivative obviously gives us the gradient of our parabola at any given point. So we are going to make f prime of n be equal to 0, and then we can solve for n. Okay, and so to solve for n here, we can just simply take 34 to the left hand side, and it will be positive 34, and we'll be left with 2n on the other side. And then we can divide by 2 on both sides in order for us to have n as a subject of the formula. So 2 cancels 2, and you see that 34 divided by 2 is nothing other than 17. And so n is 17. We are still getting the exact same answer as before. Okay, and again, this is not the only way. There is one more, technique on which you can use to find that same answer. And that would be by finding the midpoint between 14 and 12. Because the turning point is about the line of symmetry of your parabola, right? So if we find the midpoint between 14 and 20, it should give us the turning point of our parabola. And so for that one, we can say that n is equal to 14 plus 20 divided by 2, because we just want the x value of the turning point. And so 14 plus 20 is 34. And if we divide that by 2, we still get 17. And so those are the 3 different techniques that you can use. Now, for the second part of our question, we are given the geometric series 5 over 8 plus 5 over 16 plus 5 over 32, and so on, equals to k. And the first question is, determine the value of k if the series has 21 terms. Okay, And this is easy because this means that k is just the sum to the first 21 terms of that geometric series. And we can simply use a relevant formula in order for us to work this out. But of course, there are two formulas that one can use to find the sum of the first n terms for a geometric series. So in order for us to know whether which one we must use, we need to work out the r value or the ratio for this particular geometric series. And we know that to find r, we just need to divide Tn by Tn minus 1. So for an example, for our particular series here, we can take 5 over 16. 5 divided by 16, and I'll just use this division sign. And we divide that by the previous term, which is 5 over 8. Okay? And of course, if you do this division, you are going to get, you can work this out by taking down 5 over 16, change the division to a multiplication, and then invert the second fraction into 8 over 5. And so 5 is going to cancel with 5, and 8 goes to 8 once, but 8 goes to 16 twice. So the answer here is 1 over 2. And of course, you can also work this out by taking 5 over 32 and dividing it by 5 over 16. This will also give you 1 over 2. Because in a geometric series, you have a constant ratio between any consecutive terms. And so our ratio r here, we can now conclude that our r value, which is equal to 1 over 2, is less than positive 1, right? And if that's the case, it means that the relevant formula that we must use is Sn is equal to A into 1 minus r to the power of n. All of that divided by 1 over r. And of course, our A value is 5 over 8 because A is always the first term in your geometric series. And we want to work out the sum to the first 21 terms of our series because that's what the value of k would represent in this question. So we want the sum of the first 21 terms in our geometric series. And our A value is 5 over 8. So for A, we have 5 over 8. So we multiply that by 1 minus our r, which is 1 over 2. All of that, this ratio should be to the power of 21. So it's very important to include these brackets since this is a fraction, right? And then we divide that by 1 minus 1 over 2. And this here should give us the value of k. And so we can simply solve this using a calculator. So we have 5 over 8 multiplied by 1 minus open bracket 1 over 2 to the power of 21. And then we close brackets and we divide that by 1 minus 1 over 2. And this gives us 1,25 if we round off to 2 decimal places. So we get 1,25 as our final answer. Okay, so this means that the value of k if the series has 21 terms will be given by 1,25. And now the next question here is determine the largest value of n for which Tn is greater than 5 divided by 8,192. Okay, so for this one here, it means that we need to solve an inequality, right? And in order for us to be able to do that, it means that we need to start by working out the general term Tn for our geometric sequence. And so the general term for a geometric sequence is always given by Tn is equal to a r to the power of n minus 1. Okay, and for our particular geometric sequence, we know that our first term a is 5 over 8. There it is, 5 over 8. And so we write 5 over 8 here. And our rate is half. So we have 1 over 2 to the power of n minus 1. Okay? And so if we sub that into our inequality, we are going to get 5 over 8 multiplied by 1 over 2 n minus 1 is greater than 5 divided by 8,192. So we simply need to solve this inequality here. And so what I would propose that we do here is we can start by removing 5 over 8 here, and we can do that by multiplying on this side by 8 divided by 5, which is the reciprocal of 5 over 8. And we obviously need to do the same thing on the right hand side, right? And so after doing this, 8 cancels 8 and 5 also cancels 5, so that we are only left with 1 over 2 to the power, all of that to the power of n minus 1. But 1 to the power of any exponent is always 1, right? For example, 1 to the power of 100 is 1. 1 to the power of 10 is 1. 1 to the power of any number basically is always going to be 1. So we can just leave 1 like that, and then we write the n minus 1 here in the denominator for 2. And on this side, we note that 5 can also cancel with this 5 here. And then we will be left with 8 over 8,192. And let's see if that can be simplifiable. So 8 divided by 8,192. So yes, in fact, these numbers do have a common factor, and we get that this can be simplified to 1 divided by 1,024. 1,024. And now that we have that, here is how I would try to work that out. So we want to write that 1,024 with the base of 2, right? So I will try different exponents there to see if I can possibly get 1,024. For example, let's say we start with to the power of 6. That is 64. So it's still less than our target. We go to 7. Okay. And so for example, I can start with, let's say, 15. Okay, that's too much already. Let's say 9. Okay, that's less. Let's say 10. So it's 10 is the right exponent. So it means that we can write 1024 with the exponent of 10, right? So I'm gonna keep everything else as it is. But now in place of 1024, I'm gonna write 2 to the power of 10, right? And now the numerators here are already the same, right? What I am going to do is I will simply use this law of exponent, which is that if, for example, you have 1 over x to the power of n, you can write this as x to the power of negative n. So that's what I'm going to apply here. So on the left hand side, we are going to have 2 to the power of negative n minus 1. And note how I put all of that in brackets. And then likewise on the right hand side, we'll have 2 to the power of negative 10. Okay? And now since the bases are the same here, it means that we can simply write this as negative n minus 1 is greater than negative 10. Okay? And now from this step, since our bases are the same, we can just take down our exponents, right? And we can get rid of these negative signs here by multiplying or dividing by negative 1 on both sides of the equation. If we divide by negative 1 and divide by negative 1 here, we are now going to be left with n minus 1. And now it's important to remember that in inequalities, if you divide or multiply by a negative, the inequality sign also changes, okay? And then on the right hand side, we'll have 10, okay? And so this means that n is going to be less than 10 plus 1. If we take 1 to the right hand side, obviously its sign is going to change to positive. And so we have n is less than 11. Okay, but we have not answered the question yet. Let's review the question. So the question was, determine the largest value of n for which our inequality is true. So we want what? The largest value of n. The largest. Take note of that. And so, for example, graphically, we can represent this solution as follows. So we have 11 there, and our solution here is n is less than 11. So less than, we are going to that side, to the left hand side, and we do not include 11 because we do not have or equal to here. We just have less than. So since we want the largest value, and also remember that n here are integers. So n are integer values, right? If this is our solution lies on this side and we want the largest integer value, that integer value must be 10, because 10 is the integer value that comes before 11. That will be the largest value. For example, we cannot take 9 as our solution because 9 is not the largest value, because the largest value is what is 10. And therefore, our final answer is n is equal to 10. So 10 is the largest value of n for which our inequality is true.